Good morning, guys. Today we're going to be looking at some notes that I want you to be taking and a worksheet that I want you to be filling in. This one here, slope and lines. So I'll be going through some of the ideas with you and helping you answer some of the questions. Now, before we really want to get into it, I just want to review kind of the idea of what we've been seeing. Let me start with just another example. Let's say somebody were to show you a picture of some people in your class and say, well, that's not everybody in my class. I know these guys. There's this guy here who, I don't know, let's say I recognize that guy, and that's Aaron. And this guy over here, well, he's Axel in the background, and I know that's Abraham. You see a picture of these people, and you know who they are, and you can sort of figure out a little bit about them just from looking at them. And let's say instead of having that picture, somebody gives you not a picture of your friends there in your class, but actually shows you a list of their names. So you see, oh, that's some of the people in my class, but not everybody. And you might be able to look at this information and get kind of the same information you get from looking at their pictures, right? This is one way of showing you these 5 people, and then their names is another way of showing you those 5 people. And then somebody else might come along and not show you a picture of them, not show you all their names, but they might show you this idea. They would say, okay, this is just a sentence. Everyone in class whose name starts with the letter A. And if you go back and look at the picture, you're like, oh yeah, that's right. I guess all these people, that's Andreas, that's Anthony, that's Abraham, that's Axel, that's Aaron. All those guys, their names start with the letter A. And if I go back and check the list of names, well, I see it's the same information as well. So really, these 3 things are the same thing, just shown in different ways. This is showing you a rule about what's going to be in the picture. This is showing you an actual picture of the people, and this is showing you a list of their names. And in your head, all these things really kind of are the same thing, just expressed in different ways. So it's kind of what we're doing when we're looking at tables of values, when we're looking at graphs, and when we're looking at rules. And when I say rule, I mean an equation. So for example, if I show you this picture, this is like seeing a picture of those 5 guys in your class. You've got a picture here of a whole bunch of points all strung together. And here it's not just 5 guys, there's actually an infinite number of points all showing up in this picture. So it's a little bit different in that way. But in other ways it's similar. If I were to give you a table of values like this, then you might notice that a lot of these values are showing up here. Like this point here, -5 for x, -3 for y. That's actually in the picture here. That's this guy over here. 0 and -2, that's in the picture as well. 5 and -1, that's also in the picture. 10 and 0, I guess he was too far outside of the picture for us to see him. But you can see how if the line kept going, maybe you can imagine it would keep going to 10 and 0. Right, so really this picture is a lot like this table of values. They're the same information shown in 2 different ways. And finally, there's actually a way I could write this just like this. Y equals 0.2x plus -2. Now what that is, this is when I write this, that's like me saying every kid in the class whose name begins with A. It's the rule that's telling me who's going to show up in the picture and also whose names I would list if I were listing all those people's names. This is another way of giving this information, and both of those are other ways of showing this information. Okay? Now you see here this equation, y equals 0.2x plus -2. It may not be obvious why this is the same as this line and the same as this table of values, but you've probably seen us getting to that over the course of the past few classes. Right? Like you see, the reason why this is the same as this is if I take this x here, -5, and I plug it in here, 0.2 times -5, I put the -5 in for the x, 0.2 times -5 would actually give me, I gotta do this on top of my head, that's gonna be -1. And then -1 plus -2, if I simplify that, -1 plus -2 gives me -3, which would give me y is -3. And you see that's why the -3 is there. If I were to plug this x in here, I do 0.2 times 0. That's the 0 I'm putting in for the x. 0.2 times 0. I know that one. 0.2 times 0 is 0. Then I add -2 to that, and I end up with -2. So if x was 0, y becomes -2. And if you look here, if x is 0, y is -2. This equation is giving me all these points. Let's try one last one. If I plug 5 in for x, I do 0.2 times 5. You could either do that in your head, on paper, in a calculator. Either way, it'll tell you that 0.2 times 5 is 1, and then 1 plus negative 2 would give me negative 1. So when x is 5, I simplify this whole side and I get negative 1. X is 5, y is negative 1. If I were to plug in x is 10, you can predict I would end up getting that y is 0. And if I were to take all these points again, put them on the graph, I see a picture of it. If I started out with this graph, I could also see that I'd get a list of points. I can look in the picture and see whose names I recognize the people in the picture, put them in a list here. And we'll also see you can take that list of names and figure out in your head, oh, that's everybody whose name starts with A. That's what that rule is, if I look down here. Now, how we're going to do that, one of the things that we've been looking at in class so far is how, from looking at a line, you can figure out what the rate of change is. Right? And we've done that a couple of ways. We've done it what I've called the quick and dirty method, where you count the rise and then you say that over the run. Right? Here the rise would be 1 and the run would be 5. If I'm going from this point to this point, I rise up 1 and over 5. So my rise over run would be 1 over 5, which some of you guys might have noticed. 1 over 5 and 0.2 are the same thing, right? They're just two different ways of saying the same thing. And what we haven't looked at as much, but we've started to see, is this other number here, the negative 2. That's just where this line crosses over the y-axis. That's what the negative 2 is. And you can write any equation like this if you just say to yourself, it's y equals some number in front of an x, some coefficient for an x, plus some other number. And that first number we've been talking about as rate of change or as slope. We just use the letter A to represent that. And the second number, which is where this line crosses over the y-axis, that number in this case is minus 2, but we just call it B, or put another way, we say that it's the y-intercept. So we're always writing y equals some number times x plus some other number. And that first some number, which we usually call A, is your slope. And that second some number that you put right there is B, that's your y-intercept. Okay, now let's look at this in some of the examples that you've got in that sheet there. Okay, so what I'm going to be doing now, I'm just going through this sheet here. It starts, so there's a title at the top, slope and lines, and I'll be moving through some of these one by one.